So today we will be discussing the typical water supply system, the component of water supply system, and how to plan a water supply system, and how to estimate the existing water supply system, and how to find between the existing and to cope the demand of a society, community, or a village system. So this is the flow diagram of a water supply system, starting from a water source consisting of a, surface water. It may be the groundwater, it may be the hand pump, and depending upon the condition. So basically, we check the first of all the quality of a water source. If it is not viable, then we provide it as some basic treatment by it may be the coagulation, sedimentation, filtration, and disinfection. So from depending upon the quality of a water source, we may provide different type of treatment to that water source. So after treatment of that water, we then store in some storage. It may be the ground surface reservoir or it may be a sump. Then again after storage, we then pump through a rising main to the secondary storage, elevated surface storage, or the ground surface storage. After groundwater storage, we then distribute it into the water supply, the whole the water supply network, and then provided water through stand post, the washing bath, the hard hose pipeline, and kettle trough. So these are the different sources of the component of a water supply system. Starting from a sources, it may be the open well, tube well, hand pump, pond, dam site, external pipe supply, rainwater harvesting system tank. Uh, if treatment is required for that source, so it may be the reverse or osmosis system. It's basically a filtration system, but here we filter the water through force by providing some forcing main to filter the required source of water. We can treat through chlorination, sedimentation, and sand filter, etc. After that, we then store the water depending upon the condition in the elevated surface reservoir, ground surface reservoir, or maybe in a sump. After storage of water, we then distribute in the main line, the transmission line, sub main line, branch pipeline, household level tap, stand post, and washing unit. So this is a schematic diagram of water supply system. We collect the water from the source through pumping and store in some primary storage, and then if it is required a treatment, then we go provide a treatment, and after treatment it's stored in the secondary storage. After secondary storage, we then pump to the storage or a high elevated tank. So we can provide a water through some head to the community or a society. So sources of water. So there are different sources of water. Groundwater. Groundwater may be the open well, tube well, bore well, hand pump are sources which make water available from ground. So open well basically is basically when the water is present at a shallow depth is about 15 meters. So we mostly use open well, but this practice is currently not mostly used in most of the places. So due to advanced technology, we are mostly using the tube well, but in a place where is like a DI Khan place in the south area, where the electricity shortage and other other scenarios, we can make to provide tube well or other system like that. So if mostly the open well are provided in like these areas. Hand pump, where the water is mostly available up to 60-meter depth, and hand pump is provided for that for the fulfilling the purpose of water. The open well or the hand pump is mostly provided in those areas where the cluster of houses is not that much. So if we provide a whole water supply network for houses of about 20 to 30 houses, then it is uneconomical to build a whole water supply network and providing a storage tank or providing a pumping system to fulfill the demand. So to select a source, it depends upon the condition that which source you select for fulfilling the demand of water for any community or a village or a society. So the bore or tube well is also one of the sources. When open well and hand pumps are not viable, then we use a bore well or tube well for fulfilling the demand of water. Surface water is also one of the sources of water. A river, pond, dam site are the main surface water which can be used for the uh, for supply of water to any community. Moreover, the rainwater can also be harvested through uh, the roof of any type of a structure, building structure, and then it is passes through the filter system by using gutter pipes, and then gutter pipes are connected to the conveyance pipe, and the conveyance pipe supply the water to the filtration system where it filter the water and then it's stored in the rainwater storage system. The storage is provided to store the water, and then it can be used for different purposes. So rainwater harvesting is mostly used in those areas where the water where the rainfall is occurring day by day. Classification of source based on the availability. So mostly when the source is available in the vicinity of any community or any society or village, so we call that source is a local source. If the source is at some 1 kilometer far away from the community or society, is about 1 kilometer or at a 2 kilometer, then we call it as a distant sources. Water treatment. So water treatment is also important to provide if the quality of water is not that much good for drinking purposes. So mostly in these in that cases, the treatment is provided for the water. In water treatment process, first of all, the water is pumped through the pumping station, and then it passes to it's sent to the coagulation tank where the elements like chemicals are applied to it to make a clog of uh, of the material that are not good for drinking purposes, and then it's sent to the sedimentation tank where it settled down, and after settling down it is sent to the sludge digester, and the remaining water is then sent it to the filtration. So the filtration method may be the sand filter or the rapid filter can be applied to filter the water, and after filtration, after passing to the filtration, the water is then passed to disinfection where the chlorine is provided to improve the quality of water, and after that it is pumped through the pump to the storage. After storing a water in elevated storage, then it distributed in the distribution mainline, subline, and branches to provide water to houses. So water can also be treated as at a household. The ceramic pot can also be used by providing a fine sand, coarse sand, and gravel, and by passing water through these different layers and also providing a pores at the bottom to collect the water at the bucket, any type of system, then provided at the bottom of that ceramic pot in order to filter the water, and that water can be used for the drinking purposes. Similarly, the water can also be improved by passing through the cloth to improve its quality. And most of the in Africa countries, the ultraviolet by filling the water bottles and keep it in the sun to treat the water for the removal of a microorganism. Boiling method can also be used for the removal of organism, and similarly chlorination can also be used to treat the water for the drinking purposes. Water supply mechanism. So mostly the pump house is provided in order to secure the pumps provided for the water supply system, and panel board is also provided to control the off and on function of a pump, and the electrical oil engine is also provided if there is non-availability of electricity. Sort of by using a diesel pumps can also be used for providing the diesel pump can also be used to provide a water for the any community, society, or maybe a village. A rising main is basically the pipe connected to the storage tank through which the water is supplied from a pumping station to the storage tank. So this pipe is basically a rising main, which basically send the water or transfer the water from the pumping station to the storage tank. Water storage facilities. So there are different type of water storage facility, elevated storage tank. So it is mostly used in a water supply system to provide a head to the head at different junctions, and mostly is used where the distance between the pumping station or the community is large. So therefore, the elevated storage tank are used, or it also may be used in undulated areas to provide a head at different junctions, and mostly it is used at the height of more than 15 meter. So water can be distributed directly from the storage tank by gravity or pump. Ground surface reservoir. Ground surface reservoir is also used to storage of water in a community, mostly in a case where there are not availability of electricity for our pumping, and the pumping system are using mostly for the 8 to 12 hours in a day. So to fulfill a demand for the remaining hours, so we mostly use the ground surface reservoir in order to store the water in ground surface reservoir, and then it's transferred to the different household stand post, household taps, and for other purposes. Mostly the capacity of these ground surface reservoirs is about 1.5 to 2 times greater than the elevated storage tank. So basically, the difference in between these two is to elevated storage tank is basically provided to provide a head at different junctions, and these surface reservoirs are mostly provided not just to fulfill the head at different junctions, also because the head can be it uh, can be fulfilled at different junctions by just connecting the pumps to these tanks, or the directly per taps can also be connected to these tanks to fulfill or to carry the water from these tanks. Some is just like a ground surface reservoir, but it is installed under the ground. Mostly the capacity of these some are about 5 to 6 times greater than the ground surface reservoir or the elevated storage tank. And these are mostly uses in a case where some interruptions occurs when due to the some effects in the water supply system, due to some damage in the water supply system, or due to some the damage the pumps using in for the supply of water to different to different houses or taps or household stand post. So in that case, when the pump is not functioning or the water supply system not properly functioning, so the sum is that it uses for the supply of water to the community. Water distribution. So water can be distributed through gravity system, mostly in a hilly areas. The gravitational field distribution system are used is just like that. So the figure shows the dual system where the pump is also provided to fulfill the demand of any society or a city, and the ground on the source at a high point is provided to fulfill the demand by just gravity, just by gravity. So this is basically the figure showing that the combination of both pumping and gravity system. But in a single gravity system, mostly no pumping is provided, and just what is supplied to this society through gravity. Pumping system. In pumping, so pumping system mostly provided without a storage or maybe a storage. Storage is basically elevated storage is basically provided when there is undulated areas, and there is some storage of the lack of electricity problem and in these areas. So the pumping system with the storage is provided. Mostly the diesel pumps should also be provided In order to, if there is the electricity problem, so the diesel pumps can be run to fulfill the demand of a community. So the pumping system with the storage can also be provided to store the water in an intermediate place and then transfer to the houses by providing a head from the storage tank. Dual combination, basically, I have also explained here that this combination of pumping system and by providing water to a city or community through gravity system. So these numbers are basically according to the Indian standard. We will study about our Pakistani standard in the next lecture, inshallah. So minimum residual pressure in a distribution system should be of 7 meter for a single story, 12 meter for a 2-story, and 17 meter for a 3-story building. So it's just like, for example, we have a water supply system, and it is connected some household. So for example, the height of the story height of the story height of that house is about 8 to 9 meter. So for a single story, so the water addition that junction should be provide a head of about 7 meter in, and should be able to fulfill the tank if it is available at the roof of that house. So should able to supply a water to fulfill that to full the storage tank, and then able to work where there is no pumping hours to fulfill the demand at that location. Distribution line, the lines carrying water from a storage to its end, standpost, household, tap, etc. are called the distribution lines. Only a distribution line may be the main transmission line, the subline, the branch lines, and the laterals are connected to the branch lines. So different type of materials can be used for the distribution line: mild steel, galvanized iron, high density polyethylene, and say PVC pipes, ductile iron. So different type of material of pipes can be used in for a distribution line depending upon the demand of a system. Standpost just like a tank, providing with a tap at the one side to fulfill the demand. So mostly the one stand post is provided according to Indian standard for every 250 person, and have a capacity of have a discharge of 12 liters per minute, and each stand post should be in the is about 500 meter from the targeted household. Types of water supply system. So in continuous water supply system, we provide a water for 24 hours. So in that system, the advantage of this system is that the water remains fresh, no rusting of pipes occurs, but the losses of water is more because of if there are any leakage in the system. So in order to design a water supply system, so we should also take into account the losses occur to leakage. So mostly it's taken the value for a leakage are taken is about 10% of the demand of a water supply system. Intermittent water supply system. In intermittent water supply system, we just provide a water through pumping for about 8 to 12 hours, and intermediate flashes, number of elevated storage tanks are provided to fulfill demand in the remaining hours. So the advantage of this system is that the consumption of electricity is less, but the problem is that the rusting of pipes are mostly occur due to wetting and drying, and similarly, the maintenance can easily be done during no supply hours. So every system has some advantages and disadvantages. So depending upon the condition, you have to choose whether you should apply the continuous water supply system and intermittent water supply system. So planning and estimating the component of water supply system. Okay, to plan a water supply system, in order to if you want to design a water supply system, so you should consider different factor. If, for example, if you want to design a water supply system where there's no sewage system, proper sewage system, then the per capita demand should be of 70 liter per capita per day. These numbers are basically according to the Indian standards. For a household with the tap supply for plus the public taps or hand pump, the demand should be taken as 55 liter per capita per day. So basically in 70 liter per capita per day, the different type of works are involved, like just bathing or the washing of clothes, and it may also include the cooking. So for the water using for a drink purposes. So these are different types of demands based on which it is decided that for that type of system, that type of demand should be used. So when there is no other source except the hand pump, the open well protected ponds are available. So in such areas, the 40 liter per capita per day should be provided. And the stand post is mostly provided in a place where the is provided for about the 250% and having a discharge of 12 liters per minute, and should be provided in the 1500 buffer of a community. Okay, if you want to design a water supply system, and the for example for a urban area, and there is also the sewerage system is also provided in that area, then the demand, water supply demand, should be considered for per person per capita is 135 liter per person per day. So before designing a water supply system, you should decide that whether you want to design a system for 20 years, 25 years, or 30 years. So basically, it's the range. It may be designed for 35 years and 40 years, depending upon the condition, depending upon the weather and other factors, including the soil. So if you want to design a water supply system, for example, if you want to design a water supply system for 20 years, so you should add the also the commissioning period in which you design a water supply system, and also the bidding period and the construction period. So all these time periods should also be included in order to forecast the population for which you want to design a water supply system. For example, if I want to design a water supply system, so in 2022 I want to design a water supply system. So and I want this, to design it for 20 years. So I want to include also a commissioning period of 5 years. So I have to design it for 25 years. So the commissioning period include the design, the bidding of that design, and construction of the full water supply system. So it took time. Therefore, the commissioning period should also be included. So in our first, when you plan that you have to design a 20 for a 20 years, 25 years, the next step is to forecast the population. It is very important step to forecast the population. You cannot design a water supply system for a present population because the population increases day by day. So based on the geometric growth formula or the arithmetic formula, you can estimate or forecast the population. So these are just the some rule that for 15 years the current population should be multiplied with the 1.1, and for 20 years it should be multiplied by 1.2 times the current population in order to design, if you want to design for 20 years. Public storage tank are designed to store at least so we will do an exercise to for the population forecasting and other things stuff, inshallah, when we start to design a case study. Public storage tanks are designed to store at least 50%. Okay, in intermediate water supply system, the storage basically provided should have a capacity of 50% to fulfill the demand of the daily requirement, about 50%. And if you want to calculate the demand, then you should calculate the peak demand for a water supply system. For example, if you have average demand, then you should calculate the peak peak factor. So the peak factor basically calculated in such a way, like for example, we have a year. In year, there will be there will be a month where the high demand will be occurring. For example, there are, for example, 4 season in a year. So in summer, mostly in a summer, the demand is high for each person. In summer, mostly the June, July, August, June, July, or August, the demand in these months are very high. And in these months, one day is such that the demand and that days is, or the week at that month is very high. So we calculate the P factor on the in such a way that it should represent the peak demand throughout the whole year. So we have to design that peak demand. So peak factor is calculated. We will inshallah do some examples on that inshallah when we start a case study, and how to calculate the peak factor for any community, and based on that how to calculate the average or the total demand for a society. These are just some rules according to the Indian standard, but we can easily calculate the length of a total distribution pipeline using a software. Similarly, you have also decide the service life for a storage by a dam, for example, for a pump house, using a pump house in a water supply system, service reservoirs. So these are different numbers for different component of a water supply system that should be considered in order to design water supply systems. So first of all, when you start a design a water supply system, you have planned that I have to design for a 20 years or 25 years. After that, you have to choose that whether you want to design for a village, for an urban area, what type of system you want to design, a continuous system, intermittent system. So based on that, you have to decide whether you will take the 40 liter per capita per day, 70 liter per capita per day, or 35 liter per capita per day. For example, if I want to design for an urban area, and the sewerage system is also provided there, so I will use the 135 liter per capita per day. But where the sewerage system is not provided in these areas, so I will use a 70 liter per capita per day. So the present population is calculated based on that existing population. The population is forecasted based on the 15 years, 20 years, using the geometric growth formula or the arithmetic growth formula. So based on that, the water requirement, we also know about the water requirement, that is about 135 liter per capita per day. So when we multiply the forecasted population, we get the total demand per day. And then when we multiply it with the 365 days in a year, then we calculate it for a water demand for a year. So after calculating the demand of a system, we have to calculate that what type of sources are available for us to fulfill the demand of that society. So we have to check whether we have a surface water, pond, groundwater, have hand pump, open well, bore, tube well. So what type of sources when we can use to assess the drinking water availability, or to assess the or to fulfill the requirement of a village or a city or a community or a society. So first of all, you have to determine what are the numbers of these sources. They are or twin numbers or foreign numbers. So after that, you have to find the total availability in these sources. For example, if you want to the availability of a surface water like a river or a stream, so the cross section of that area, for example, it is a river, and the water is flowing through that river. So the cross section at a specified location can be determined by using different method like a total station or the level. Different type of methods can be used. The width can be calculated. Similarly, the depth at different location can also be calculated, and by taking the average of that depth multiplying with the width of the river, we can get the area. and by using a pitot tube or different instrument which can measure the velocity, so we can measure the velocity through the of a river or a stream by different instruments which are recently available. So multiplying with the area, we can get the discharge. If we get the discharge, then we can convert it to the probably we will get that in a meter cube per second or liter per second. Then we can convert it into the liter per day, and ultimately for a year by multiplying with the 365 days. So total availability for a surface water can be determined in such a way. So the availability of a water can also be determined as summer, winter, monsoon, because the water varies through seasons. So the water availability for a ponds can be determined. For example, we have pond. So the cross-section area can be calculated using a survey, like using a level total station, or even a drone survey can also be used to make a surface of contours of that pond. And using AutoCAD and different type of software, we can calculate the area of that pond, and the depth can also be calculated. So we can calculate the storage capacity of that pond, and we can then based on the storage capacity, we have also to consider whether it is partially full throughout the year. So wait for a while. हेलो खालिद भाई, आवाज दर्जी?
जी जी राजी।
सही सही, मात्र इंटरनेट कनेक्शन स्टेबल ला मुझे लग कंफ्यूज हुआ. Okay. So after finding the area of a pond, we can calculate the depth of that pond. So by multiplying the area with the depth of that pond, we can calculate the volume capacity of a pond. So after volume capacity, finding the volume capacity of pond, we can also we then calculate the availability of a water based on the whether it is partially full throughout the year, full the pond is full throughout the year, or as the half full throughout there. So based on that, we can calculate, for example, if we calculate that the cubic capacity of about 1000, and it is available about, it is half full throughout there. So based on that, we can calculate the total capacity of storage. Yeah, you will have to consider these parameters also, the different coefficient, like the infiltration. So these different factors should also be considered in that as well. So the availability for estimating with water availability from hand pump will be considered in such a way that you have to find the average working hours per day. What are the number of sources available, 2 in number, 3 in number, or 4 in number, the average working hours per day, the average discharge rate per hour, per day availability, number of functional days in year, and total availability in year. So how to calculate the discharge from hand pumps? Okay, I'm going to start another session. It's going to end this session. Stop recording.